So this video is going to be about scientific notation. We use scientific notation in chemistry and lots of other sciences because we deal with really big, really small numbers. For example, this number that's written on the board is roughly the diameter of an atom. So we're going to be dealing with sizes of atoms, so diameter, mass, and so on. So we need to come up with a system that's easier to use than this, which is a little cumbersome. So that's why we use scientific notation. So just a quick recap of some basic vocab that we'll be using. Standard notation is just the normal way we write numbers, so just like this, 1, 2, 3, 4, 5, that kind of thing. Scientific notation looks more like this. We've got a number that's between 1 and 10. We call that the coefficient. The base is always 10, and the reason for that is that we always multiply, in scientific notation we're moving the decimal. So moving the decimal means multiplying or dividing by factors of 10, so the base is always 10. The exponent is going to tell you how many times the decimal gets moved or how many times you need to move it. So the guidelines for scientific notation are written here, and you'll also have notes on these. So we started off with this long number, so to get the coefficient, what you do is you're going to move the decimal in between the first two, or after the first non-zero digit. So the first non-zero digit in this case is 1, and then the next one after that is 8, not 2. So we've got two non-zero digits here, so the decimal is going to go in between those. And if we move the decimal in between 1 and 8, we actually get 1.8. And so what we're going to do is count how many times we moved it, and that's going to give us the exponent here. So when I do scientific notation, I always do this same quick method. It just helps me keep track of the number of times, but you don't have to do it. So I start with the decimal, and I do this little loop-de-loop to count how many times I moved it. And in this case I moved it 11 times. So the exponent does not tell you how many zeros to put in. It tells you how many times to move the decimal. And so I moved it 11 times to get it from here to here, in between the two non-zero digits. And because I had to move it this way, my exponent has a negative sign. The way to tell whether you're going to have a negative or positive exponent is to look at what the number starts with. If it starts with a 0, it's less than 1. So if it starts with 0 point something, then your exponent will be negative. Even if you had a really small a really simple number to deal with, like 0.05, you'd actually have a negative exponent as well. So if you have a bigger number, so it starts with a number, not just 0 in this case, your exponent will be positive, and I'll show you an example of that in a second. The exponent, like I said, tells you how many times you need to move the decimal, and in this case we moved it 11 times. So I'll go through a different example, and then we'll try some practice. But just a quick recap of the general rules or guidelines. The coefficient, or the number, has to be between 1 and 10, and you're going to move the decimal to get it in between 1 and 10. And in this case it was 1.8. The base is always 10. If the number starts with a 0, like this one, it's going to have a negative exponent. If it's positive, you're going to have... if it starts with another number, or a non-zero number, then it's going to be a positive exponent. The exponent tells you how many times to move it. So let's just erase this, and we'll try a different example. So the distance from Earth to the Sun is this many million miles. So rounding it up is actually 93 million. So to write that number in scientific notation, we need to know that the decimal is on the end of the number. For a number like this. So we're going to move it in between the 9 and the 3. So 93 is not between 1 and 10. neither is 0.93. So 9.3 is between 1 and 10, so that fits our criteria. The base is always 10, so that bit's always the same. And I moved the decimal, 1, 2, 3, 4, 5, 6, 7. So 7 times. The exponent is going to be positive in this case because my number starts with a non-zero, or it's bigger than 1. So that's scientific notation. Just another couple of quick notes about scientific notation. And it actually recaps some exponent rules from algebra a long time ago. If you have a number, we don't actually use this sort of scientific notation for numbers that are that small. But you could have a 1 as your exponent, you could have a 0, but this will be equal to 50. And so anything to the power 1 is that number. The base stays the same. So 10 to the power of 1 is equal to 10. So what we wouldn't usually write that 1 for the exponent. So 5 times 10 is 50. So if you had this as a scientific notation problem, or you were faced with this in a situation, anything to the power 0 is always equal to 1. So this would be 5. So 5 times 1. So those exponent rules that gave you so much grief have come back to haunt you. So this is scientific notation. Just a quick recap. Makes life a little easier. Definitely not for numbers like this. You just write 5 times 10. It's just easier to write 50. So not always applicable for smaller numbers like this, but bigger numbers with lots of zeros, really, really tiny numbers like the mass of an atom, the mass of an electron. We're going to use that quite a lot. So scientific notation is going to be helpful. And so in the next video, I'm going to go over operations. We're going to be using some multiplication and division with scientific notation. That will be next. But just actually before I do that, let's do an example, or a couple of examples, dealing with going from scientific notation into standard notation, because we just did it standard into scientific. So let's say that you have a number in scientific notation, and you've got to write it in standard notation, so the regular way of writing numbers. There's different ways to do it, but what I do is start with the coefficient, and then I'm going to move the decimal 8 times. Which direction do I need to move it? Well, I know that anything with a negative exponent is going to be less than 1, so that means I move it to the left. So if that was positive, I'd move it to the right. And I'll do an example of that in a second. So I've got to move the decimal 8 times. So I move it once, put a 0. Twice, put a 0. So 1, 2, 3, 4, 5, 6, 7, 8. So this could be like this scratch work, if you will, and you could rewrite it just to be neat. So from scientific notation into standard, this is one way to do it. If you've got a different way to do it, that's perfectly fine. If you look at that and go, well, I'm going to have 7 zeros in front of that 9 and get rid of that decimal. Either way. If this way works for you, great. So let's do an example of a positive exponent. Just to finish this off, switch to blue pen. So 5.38, let's try a different number. Same rules apply even if you've got more digits, non-zero digits here. So let's try this. We've got a positive exponent this time, so I'm going to be moving the decimal that way because any number that starts with a non-zero digit is going to have a positive exponent. So I know that this is going to start with a number, a non-zero number. So in this case we've got 5, 3, 5, 8, and I'm going to move it 5 times. So the decimal starts here. So 1, 2, 3, 4, 5. 3, 5 decimal. Well, we wouldn't write the decimal in that case, but that would be our answer. And that's scientific notation.